Today we're going to talk about gases, and specifically we're going to talk about pressure, KMT, and the gas laws, basic gas laws, when we're doing calculations both quantitatively and qualitatively with gases. So first thing, just a little refresher, 3 states of matter here. We have solids, liquids, and gases. And we can clearly see as we move from a solid to a liquid to a gas, the particles, the atoms, the molecules become much more spread apart. They are moving much quicker, they have a lot more kinetic energy, and they're not interacting as frequently. We can see here interactions increasing towards solid, decreasing towards gas. And the reason for that is these molecules are just further apart. They're spread apart, they're filling up more volume, there's less interactions occurring between molecules. And a lot of these properties fall under KMT, which stands for kinetic molecular theory. And what kinetic molecular theory does is it gives us a set of rules, a set of guidelines to describe the motion of gases. And there's a few things that we need to know. The gas molecules move fast, on the order of hundreds of miles per hour, depending on their molecular mass. Gas molecules also move in straight lines, okay? Unless they collide with a surface or other molecules. Gas molecules have no brain, they just move, boom, in straight lines, boom, unless they bounce off of a wall, or boom, they bounce off another molecule. And what this allows us to do is it allows us to make very accurate predictions and models, quantitatively and qualitatively, about the behavior of gases. When we're talking about gases, the main property that we're going to measure is pressure. So what is pressure when we're talking about the pressure of a gas? Well, pressure is just equal to a force per unit area. So basically what we're measuring, when we're measuring the pressure of a gas, let's assume a gas is in this container here, and here's some surface area, okay? When these molecules, boom, collide with that surface, they're exerting a force on this side of the wall. If the force increases, then we can clearly see that pressure is going to increase as well. So what are some ways that you can increase the force here? Well, if the molecules move faster, then they're going to be colliding with more kinetic energy. That's going to exert more force. If we have more molecules, that's going to make more collisions with the surface. That's going to cause greater force and therefore cause a greater pressure. So basically what we can see here is pressure is directly tied to the number of collisions with gas molecules have with a surface, not with each other. For example, if this gas molecule collides with this gas molecule, it's not exerting a force on this surface. So pressure only comes from, the only way we can measure pressure of a gas is when gas molecules collide with a surface. And if they are colliding more often and with more speed, they're going to exert a greater pressure. What are the units that we measure pressure in most typically? Well, there's a bunch of them that we got to be familiar with. There's pascals, which is abbreviated PA. There's kilopascals, which are KPA. There's torr. There's millimeters of mercury, mmHg. And there's ATM, atmosphere. We got to be familiar with all of these and how to convert between all of them. The relationships are pretty simple. 1 atmosphere, this is what air pressure is at sea level. So right now, as you watch this video, the pressure being exerted on you by the atmosphere is about 1 atmosphere, okay? 1 atmosphere is equal to 760, with 3 sig figs, millimeters of mercury, which is equal to 760 with 3 sig figs, torr. This is equal to 1.01325 times 10 to the 5th pascals, which is the same thing as 101.35 kilopascals. Again, the majority of these relationships are on your equation sheet, but what you need to be able to do is if you see any of these units, you have to recognize immediately that you're talking about pressure, the pressure of the gas. Okay? We'll do practice with conversions and with calculations, but you should be able to do these relatively easily due to our recent practice with stoichiometry. With gases, there's also a few relationships that we need to know between different properties of gases. So if we're ever talking about with gases their temperature, their pressure, or their volume, there's three main gas laws that we need to know. And this should sound relatively familiar from regular chemistry. The first one we need to know is Boyle's law. And Boyle's law is the relationship between pressure and volume, P and V. And what does Boyle's law tell us? Well, let's look at an example here. Here's a piston, like in a car, with a gas inside. Okay? And what we have is some pressure P1, some volume V1. Okay? Let's see what happens as we decrease the volume. Okay? So look, V2 is less than V1. So volume has decreased. What does that mean is going to happen to the pressure of the gas? Well, let's think back. What does pressure mean? Pressure is the force per unit area. So if we have more force, if we have more collisions, that means we're going to have more pressure. If we have less force, fewer collisions, we're going to have less pressure. Well, the volume here is much smaller than here. So we can see that in V2, these molecules are going to be colliding with each other much more often, with the surface much more often, simply because there's less space for them to move around. So as this volume decreases, the number of collisions is going to increase. And therefore, if the number of collisions of gas molecules with the surface increases, that's going to lead to an increase in pressure. So since as volume drops, pressure increases, these are moving in opposite directions, we would say that pressure and volume are indirectly related, or inversely related. If volume goes down, pressure goes up. On the other hand, we could say if volume goes up, pressure would go down. So what we need to recognize is qualitatively how to apply this, but also quantitatively. So the relationship for this would be P1 V1 equals P2 V2, where the idea is 2 represents like new or final conditions, and the 1s represent our initial conditions. So if you're given any three of these variables, you can figure out the fourth just with a little bit of algebra. But what you need to know, main takeaway, pressure, volume are indirectly related. We also want to see these relationships graphically. So if we had a volume pressure graph like this, as pressure increases, we know volume is going to drop. So the graph we would see would look something like this if we were plotting a pressure-volume relationship. What about Charles's law? What does Charles's law represent or relate? Charles's law is the relationship between temperature and volume. So what we can see here again is we have a gas in two separate pistons. Here, the relationship or the temperature is negative 10 degrees Celsius. In this gas, we've heated the temperature up to 250 degrees Celsius. Quick little side note, we always want to deal with temperatures in Kelvin. Kelvin. And remember, Kelvin is equal to degrees Celsius plus 273.15. Again, this is on your equation sheet, but you need to know how to make these calculations very quickly. Temperature always needs to be absolute. It must be in Kelvin if you're going to do any math issues. But for now, we're just comparing these qualitatively. Obviously, the temperature's gone up. Well, what's going to happen? If we increase temperature, that means molecules have more kinetic energy. They're moving faster. If they have moving faster, they have more energy. So if they collide with a surface, the number of collisions is going to increase. These gas molecules are going to collide more frequently because they're moving faster. You can see these little arrows here representing the speed that these molecules have. So if they move faster, what is that going to do to the volume? that's going to exert more force, which is going to cause the volume of this gas to increase. So we can see that as temperature increases, volume increases as well. So since these are moving in the same direction, we would say that temperature and volume are directly related. Therefore, the relationship mathematically between these would be V1 over T1 equals V2 over T2. Again, where the 2's represent some set of final conditions and the 1's are some initial conditions. Graphically, what would this look like? If things are directly related and we plot volume versus temperature, we're going to get a graph that looks like this. Moving up as temperature increases, we can see volume increases as well. Last but not least, Guy-Lussac's law. Guy-Lussac's law is the relationship between temperature and pressure. What's the idea here? Well, similar logic to before. All right? As we can see here, temperature 1, temperature 3T. So here, this temperature is 3 times more. So let's just make up some numbers. 300 Kelvin and 100 Kelvin. Well, if we increase temperature, follow the same logic. We've increased the amount of kinetic energy. These molecules are moving faster. They have more force, which means that the number of collisions is going to increase as well. And if the number of collisions increases, that means the force that's exerted by these gas molecules on a surface increases. So pressure of the gas is going to increase. If these move in the same direction, we have the pattern by now. Pressure and temperature are directly related. So again, the relationship between them quantitatively would be P1 over T1 equals P2 over T2. And graphically, we'd have a similar function with pressure and temperature showing a direct relationship. One thing that you also need to be able to recognize is if we take all 3 of these relationships, Boyle's law, Charles' law, and Guy-Lussac's law, and put them together, we get something that's called the combined gas law. And this is basically a mathematical representation of all of these together. P1 times V1 over T1 equals P2 V2 over T2. Remember, anytime you're doing calculations, temperature needs to be in Kelvin. It doesn't matter what the units for pressure are as long as they're the same as each other, and same thing with volume. It doesn't matter what they are as long as they're the same as each other. So you need to know these 3 relationships, you need to know the main concepts of kinetic molecular theory, you need to know the units for pressure, and then we'll move into more complicated, challenging problems involving pressure in the future.